1 million miles from the warmth of our atmosphere, suspended in a pocket of gravitational stability, a honeycomb of gold and beryllium waits in absolute darkness. The temperature out here, at the second Lagrange point, hovers just above absolute zero. It is a merciless, silent environment, engineered not for comfort, but for the singular purpose of catching ghosts. The mirrors of the James Webb Space Telescope do not look at the universe as it is. They harvest ancient light, photons that have bled their energy across the expanding void for over 13 billion years, stretching from visible colors into the deep, invisible infrared. When this light finally hits the sensors, it is translated into data, beamed back across the vacuum to a control room in Maryland. For decades, astrophysicists knew exactly what they expected to find in this ancient data. The dawn of the cosmos was supposed to be messy, fragmented, and slow. The first galaxies were theorized to be fragile wisps of gas and dust, struggling to pull themselves together in the chaotic aftermath of the Big Bang. It was supposed to be a gradual, logical progression from darkness to light. But the data arriving from the edge of time does not show a slow awakening. Buried in the deep field images, hiding among the spectacular spirals and glowing nebulae of the modern universe, are tiny, unassuming smudges of crimson. Astronomers simply call them the little red dots. At first glance, they are unremarkable, just a few pixels across, barely registering against the black backdrop of deep space. But light is information, and when you unpack the spectrum of these specific red pixels, the numbers do not just challenge our understanding of physics. They actively break it. These dots exist at a time when the universe was less than 500 million years old, a mere fraction of its current age. According to every established law of cosmic evolution, there has simply not been enough time for anything massive to form. Gravity works at a specific rate. Gas cools, condenses, and ignites at a specific rate. You cannot build a mountain in a day, and you cannot build a supermassive structure in a few million years. Yet the light from these red dots tells a completely different story. They are impossibly dense. They are violently active. And they contain a mass of stars and ancient material so staggering that they rival the modern Milky Way. It is the equivalent of unearthing a fully functioning nuclear reactor buried deep inside a fossilized dinosaur bone. The math does not fit the timeline. The initial reaction from the scientific community was strict skepticism, a calibration error, a glitch in the sensors, dust obscuring the true distance. But as more observations were taken, as the spectra were analyzed and reanalyzed with cold, unforgiving precision, the reality settled in. The instruments are functioning perfectly. The distances are correct. The masses are real. The little red dots are not an error in the machine. They are an error in our fundamental understanding of reality. Something was lurking in the dark, infant universe, building monsters in the shadows long before the laws of physics should have allowed. And now the raw data from those distant red pixels is finally offering an explanation for how they got there. An explanation that forces us to confront a deeply unsettling truth about the mechanical foundation of our universe. To understand the severity of this cosmic violation, we have to strip away the comforting illusions we hold about the night sky. When you stand on the earth and look out into the void, your brain assumes a false sense of simultaneity. You feel as though you are looking at a static ceiling, a present tense reality. But the universe does not offer us the present. It only offers us the wreckage of the past. Light is bound by a speed limit. It takes time to cross the immense freezing deserts of the cosmos. But distance is only the first deception. The second is the fabric of space itself. The universe is not an empty room where galaxies sit like furniture. Space is a physical medium, and it is stretching apart at an accelerating rate. Imagine a siren on a speeding ambulance. As it drives away, the sound waves stretch out, and the pitch drops into a low, mournful wail. Light suffers the exact same distortion. As those ancient photons travel for 13 billion years, the very space beneath them expands. Their wavelengths are physically stretched, pulled apart by the expansion of reality itself. A fierce, brilliant blue light from a newborn star is stretched so far that it slides down the spectrum, past yellow, past crimson, and drops off the cliff of human perception entirely. It becomes infrared. it becomes invisible heat. This is the genius and the terror of the James Webb Space Telescope. It was not built to see the universe as human eyes see it. It is an assassin of the dark, engineered with massive beryllium mirrors coated in a microscopic layer of pure gold, optimized to catch the faint, stretched thermal signatures of dead epochs. The red dots it found are not actually red, they are exhausted. The light we receive has been pulled to its absolute limit, a desperate transmission from a time when the universe was suffocating in an ocean of neutral hydrogen fog. To grasp why these dots are terrifying, we must look at the mechanics of how a universe is supposed to grow up. The established history of cosmology operates on a principle of excruciating patience. Following the chaotic furnace of the Big Bang, the universe expanded and cooled into what astrophysicists call the cosmic dark ages. There were no stars. There were no galaxies. There was only a near-infinite, pitch-black sea of gas, cooling and drifting. In this dark ocean, gravity was the only architect. And gravity, for all its grand reputation, is a remarkably weak force. Compared to the explosive power of electromagnetism or the binding force of atoms, gravity is pathetic. To build anything, gravity requires staggering amounts of time. It had to gently coax microscopic variations in the gas density to pull together. Atoms bumping into atoms, millimeter by millimeter, over millions of years, slowly building clumps of mass. According to every simulation, every piece of observational data, and every law of fluid dynamics we possess, it takes hundreds of millions of years just to build a chaotic, messy dwarf galaxy. It is a grueling, agonizingly slow process of assembly. You start with dust. You compress it into the first massive unstable stars. Those stars burn fast and die in violent supernovae, leaving behind the first small black holes. Then those black holes must spend eons merging, feeding, and growing to eventually anchor the immense spiral galaxies we see today. There is a mathematical chokehold on this process. It is called the Eddington limit. When a black hole consumes matter, it does not simply swallow it whole in silence. The gas and dust are dragged into an accretion disk, spinning at a significant fraction of the speed of light. The physical friction of this matter grinding against itself is so catastrophic that it generates heat capable of outshining entire galaxies. But this violent light has a physical consequence. The radiation pressure blasting outward pushes against the gas trying to fall inward. The mathematics reveal a merciless truth. The faster a black hole eats, the hotter the disk burns, and the more violently the light pushes its food away. It is a self-regulating engine. A black hole can only consume so much mass before the outward blast of its own radiation starves it. You cannot force-feed a black hole. Physics simply will not allow it. Therefore, growing a supermassive black hole, a monster millions of times heavier than our Sun, requires an immense unbroken timeline of steady feeding. It requires billions of years of cosmic history. But the little red dots do not care about our history. When astronomers isolate the infrared data from these tiny crimson smudges and spread the light out into a spectrum, they are not seeing the faint, fragile glow of baby galaxies. The chemical signatures in the light indicate something monstrous. The light is blindingly intense, compacted into a physical space so small it defies logic. The data suggests that hiding inside these microscopic dots are supermassive black holes weighing up to 100 million solar masses. And they are fully formed at a time when the universe was barely 5% of its current age. This is the equivalent of walking into a nursery and finding a towering, weathered old man in a crib. It shatters the timeline. For these black holes to exist in the infant universe, they would have had to bypass the agonizingly slow process of stellar death and gravitational assembly. They would have had to consume matter at a rate that brutally violates the Eddington limit, crushing the laws of thermodynamics, or they were somehow born impossibly massive, skipping the line of evolution entirely. The arrogance of our previous models was assuming that the universe played by the rules we observed in our own modern quiet corner of the cosmos. We assumed a logical progression from simple to complex. We thought we understood the speed of time and the limits of gravity. But the raw data pouring down from the second Lagrange point is telling us that the early universe was not a slow, gentle awakening. It was a hostile, terrifying environment that forged impossible monsters in the dark, long before the light was ever meant to turn on. We are navigating a dark forest of dead stars and broken theories. If you seek the truth in the cold and the dark, subscribe and join us on this journey. We are going further. To truly comprehend the scale of this mystery, we must first look at how we are extracting this impossible data from the abyss. The James Webb Space Telescope does not simply take photographs. Photographs are superficial. They capture the surface of reality. To understand the mechanics of these early galaxies, the telescope must dissect the light itself, tearing it apart to read the chemical and physical secrets hidden inside its structure. This is done using an instrument of staggering precision called the near-infrared spectrograph. Inside this instrument is an array of 250,000 microscopic doors, each one the width of a human hair. By opening and closing these tiny shutters, engineers can block out the glaring light of foreground stars and isolate the faint, exhausted photons arriving from a single little red dot. The captured light is then forced through a prism, stretching it out into a long barcode-like spectrum. When astronomers look at this spectrum, they are searching for specific fingerprints. Elements like hydrogen and helium emit light at very precise, unchangeable frequencies. In a quiet, stable environment, the signature of hydrogen appears on a spectrum as a sharp, narrow, vertical spike. But when the data from the little red dots was processed, the hydrogen spike was not sharp. It was smeared. It was violently stretched out horizontally across the spectrum, creating a broad, messy peak. In the cold logic of astrophysics, a smeared line means only one thing: unimaginable kinetic energy. This brings us to the Doppler effect, the same physical principle that changes the pitch of a passing train. If a cloud of glowing gas is moving toward the telescope, its light waves are compressed, shifting them slightly toward the blue end of the spectrum. If the gas is moving away, the light is stretched, shifting toward the red. When you look at a supermassive black hole feeding, you cannot see the hole itself. The singularity is hidden behind the event horizon, a boundary where gravity becomes so absolute that even light is dragged back down. But you can see the gas trapped in its gravitational grip. Before the gas falls in, it is pulled into a flat, swirling disk, whipping around the abyss at terrifying speeds. The gas on the left side of the disk is racing toward us, while the gas on the right side is racing away. This simultaneous movement in opposite directions smears the hydrogen signature on the telescope's sensors. The wider the smear, the faster the gas is moving. And the faster the gas is moving, the heavier the central object must be to keep that gas from flying off into deep space. When the supercomputers analyzed the broad lines coming from the little red dots, the mathematics returned a velocity that left astronomers in silence. The gas swirling inside these microscopic red smudges is moving at thousands of kilometers every single second. Translating that speed into mass yields numbers that break the timeline of the universe. To whip oceans of hydrogen gas around at that velocity, the central anchor must possess a mass between 10 million and 100 million times the weight of our Sun, a fully mature supermassive black hole. And yet, this light was emitted when the universe was barely old enough to form its first primitive structures. But the mass of the black hole is only half of the nightmare. The other half is the environment in which it resides. Every supermassive black hole we observe in the modern universe is anchored at the center of a sprawling, massive galaxy. The Milky Way, for example, is a vast, quiet disk of 100 billion stars stretching across 100,000 light-years of space. The black hole at our center is proportional to the size of the galaxy around it. It makes sense. It fits the mechanical models of galactic evolution. The little red dots do not fit the model. The spectroscopic data reveals that the host galaxies surrounding these impossible black holes are shockingly, suffocatingly small. The mass of billions of stars is crushed into a physical volume no larger than a few hundred light-years across. It is an environment of supreme claustrophobic violence. If you were to stand on a planet inside one of these early structures, the night sky would not be dark. It would be a blazing, lethal dome of stellar radiation, with stars packed so tightly together that the space between them is a fraction of what we experience in our own neighborhood. It is the equivalent of taking the entire population, infrastructure, and weight of the North American continent and violently compressing it into the physical borders of a single city block. The density is catastrophic. This forces a brutal question upon the scientific community. How do you forge a supermassive black hole and crush an entire galaxy into a microscopic footprint in a universe that has just barely cooled down from the Big Bang? If the slow, steady feeding allowed by the Eddington limit is mathematically impossible within this time frame, the universe must have found a shortcut. It must have bypassed the standard rules of evolution. Astrophysicists are now digging into the raw physics of the cosmic dark ages, and they have uncovered mechanisms that are far more violent than anything occurring in the modern cosmos. The first mechanism is a theory of absolute gravitational collapse. In the modern universe, star formation is heavily regulated by the presence of dust and heavy elements. Elements like carbon, oxygen, and iron act as coolants. When a giant cloud of gas begins to collapse under its own weight, the friction generates heat. Heat creates outward pressure, fighting against the inward pull of gravity. But the heavy elements radiate that heat away into space, allowing the cloud to cool, fragment, and break apart into hundreds or thousands of smaller, stable stars. But the early universe was pristine. There was no carbon. There was no oxygen. There was only the raw, unbroken hydrogen and helium forged in the fires of the Big Bang. Without heavy elements to act as a thermal exhaust system, the primordial gas clouds could not cool down efficiently. The physics dictate a relentless war between thermal pressure and gravity. Because the cloud cannot fragment, it remains whole, growing larger and larger, accumulating hundreds of thousands of solar masses of pure, unadulterated gas. It becomes a monolithic, unstable monster. Eventually, the raw weight of the cloud overpowers the outward pressure of its own heat. And because it cannot break apart into a cluster of smaller stars, the entire structure collapses in on itself in one single, apocalyptic event. The core does not even have the time to ignite and burn as a star. The sheer crushing force of 100,000 suns falling inward at once rips a hole in the fabric of space-time. This is what theorists call a direct collapse black hole. Say it is a massive seed, born entirely whole in the dark, skipping the millions of years of stellar life and death. If this is true, the infant universe was not a place of quiet, gradual assembly. It was a factory of immediate, catastrophic gravity. But even a direct collapse black hole, weighing 100,000 solar masses, is still vastly smaller than the monsters hiding inside the little red dots. To reach 100 million masses, that seed still needs to feed at a rate that defies the radiation limits. This leads us to an even darker mechanism, the physics of super-Eddington accretion. We established that a black hole cannot consume mass too quickly without its own radiation blowing the food away. But there is a loophole in the mechanics. The radiation from the accretion disk pushes outward uniformly. But if the environment around the black hole is chaotic enough, the incoming gas might not fall in as a smooth, flat disk. In the dense, claustrophobic environment of those ultra-compact early galaxies, cold streams of pure hydrogen gas might be flowing directly into the galactic center, like rivers of dark matter. If this gas falls inward in thick, dense columns rather than a uniform cloud, the radiation from the black hole cannot push it away. The intense light simply escapes through the gaps between the cold streams, while the massive rivers of gas punch right through the radiation pressure, feeding the singularity at a terrifying, unregulated pace. It is a cosmic gorge. The black hole swallows the surrounding galaxy at a rate that breaks the standard thermodynamic models, swelling to monstrous proportions in the blink of a cosmic eye. And there is a third, even more unsettling possibility buried in the mathematics. A theory that suggests these black holes were not formed by stars, nor by collapsing gas clouds. They may be older than the gas itself. To explore this, we must look backward, past the formation of the first atoms, past the cosmic dark ages, right to the infinitesimal fraction of a second after the universe was born. In the violent boiling soup of the early expansion, reality was governed by quantum mechanics. Microscopic fluctuations in the fabric of space meant that some regions were slightly more dense than others. As the universe underwent rapid, explosive inflation, these microscopic quantum fluctuations were stretched out to macroscopic scales. In the densest pockets of this primordial fire, the concentration of mass and energy was so absolute that space itself simply gave up. Black holes were formed not from dying matter, but from the raw, unrefined geometry of the universe itself. These are primordial black holes. If they exist, they have been drifting through the void since the very beginning of time, serving as the dark, invisible anchors around which the first galaxies were forced to assemble. The data from the little red dots is forcing us to confront the reality that one or perhaps all of these violent mechanisms were active in the deep past. The spectrums do not lie. The masses are real. The velocities are measured. The early universe was not a nursery. It was an engine of brutal, hyper-accelerated evolution, operating under conditions so extreme that our current models of physics are breaking down trying to describe them. And as the Webb telescope stares deeper into these ancient red pixels, the sheer scale of the anomaly only widens, because finding one impossible object can be dismissed as a freak occurrence. Finding a dozen is a crisis. We are realizing that the very foundation of how structure is built in this universe is missing a critical piece. There is a ghost in the machine of the cosmos, a force or a mechanism that allowed the darkest, most destructive objects in reality to dominate the dawn of time. There is a point in the pursuit of absolute knowledge where the machinery of human logic simply stops working. We rely on mathematics as our fundamental tether to reality. It is the language that allows us to predict the orbits of planets, the structural integrity of bridges, and the precise moment a dying star will collapse. Mathematics gives us the illusion of control. It assures us that the universe, no matter how vast or hostile, follows a strict, unbreakable set of rules. But when astrophysicists feed the raw data of the little red dots into the supercomputers that house our most advanced models of the cosmos, the resulting output is not a clean, elegant solution. The output is chaos. We have hit a theoretical wall, a brutal paradox where the two pillars of modern physics refuse to coexist. For the past century, our understanding of reality has been divided into two separate kingdoms. The first is general relativity, the masterpiece of gravity that governs the colossal, heavy architecture of the universe, stars, galaxies, and the bending of space-time itself. The second is quantum mechanics, the jittering, unpredictable rulebook that governs the microscopic realm of atoms and subatomic particles. In our modern, quiet corner of the universe, these two kingdoms never interact. Heavy things are large, and tiny things are light. Gravity rules the macro, and quantum probability rules the micro. But the little red dots exist in a state of physical extremity that forces these two incompatible frameworks into a violent collision. Inside these microscopic crimson smudges, we are witnessing the mass of 100 million suns, crushed into an arena so impossibly small that gravity and quantum mechanics are forced to occupy the exact same physical space. When you try to calculate the physics of an object this heavy confined to an area this small, the mathematics spiral out of control. The equations do not just yield incorrect numbers, they yield infinities. They produce results that require infinite density, infinite gravity, and a complete breakdown of time. In the cold, exacting discipline of astrophysics, infinity is not a number, it is a failure. It is the universe holding up a mirror to our ignorance and showing us that our fundamental understanding of how matter behaves is deeply, structurally flawed. This mathematical friction is only the beginning of the paradox. The deeper barrier lies in the very fabric of space and how it is actively tearing itself apart. To understand why these ancient black holes are breaking our models, we have to look at the invisible architecture that allowed them to form in the first place, the delicate war between dark matter and dark energy. Every structure in the cosmos is the result of a precise cosmic tug-of-war. Dark matter acts as the invisible scaffolding of reality, exerting a gravitational pull that drags raw gas together to build stars and galaxies. Dark energy acts as the repellent, a mysterious pressure woven into the vacuum of space itself, pushing everything apart. For a supermassive black hole to grow to the staggering proportions we see in the little red dots, dark matter had to win this war early and decisively. It required an environment where gravity could overwhelm the expansion of space long enough to crush oceans of hydrogen into a singularity. But our measurements of the universe's expansion rate, a metric known as the Hubble constant, are currently locked in a state of absolute crisis. When astronomers measure the expansion of the local modern universe, they arrive at one specific speed. But when they measure the ancient universe by looking at the faint radiation left over from the Big Bang, they arrive at a completely different, much slower speed. This is the Hubble tension. It is a crack in the foundation of cosmology, and the little red dots are sitting directly inside this fracture. If the expansion of the early universe was different than our models predict, the timeline for building these monsters becomes even more violently compressed. It means these black holes were not just fighting against the outward blast of their own radiation, they were fighting against a geometry of space that was rapidly changing the rules of gravity on the fly. Trying to assemble 100 million solar mass black hole under these conditions is like trying to build a towering skyscraper out of wet sand while the tectonic plates beneath your feet are actively ripping the continent apart. The physical friction is insurmountable. And yet, there they are, glowing fiercely in the infrared data, ignoring the mathematical impossibilities. The barrier we are hitting is not just theoretical, it is a literal, physical wall of information. We are constrained by the unforgiving mechanics of light and time. Think of the universe as a vast global server network running on a strict, unbreakable latency. The speed of light is the absolute bandwidth limit of reality. When we look at our own sun, we are experiencing an 8-minute lag. When we look at the Andromeda galaxy, we are dealing with a 2 million year delay. But when the James Webb Telescope targets the little red dots, it is pulling data across a latency of over 13 billion years. The sheer distance the information has to travel creates a severe degradation of the signal. We are attempting to reverse engineer the most violent, catastrophic engines in reality by analyzing a handful of exhausted, stretched photons that have survived a journey across the expanding void. Worse still, these photons are arriving from an era known as the epoch of reionization, a time when the universe was physically hostile to light. Before the first massive structures ignited, the cosmos was entirely filled with a thick, suffocating fog of neutral hydrogen gas. Unlike the transparent vacuum of modern space, this primordial fog was opaque. If you were to shine a blinding spotlight into this early universe, the light would travel only a microscopic distance before it was completely absorbed and extinguished by the neutral atoms. The universe was blind. The only way the light from the little red dots reached our senses is because the monsters hiding inside them were so violently hot, so unfathomably energetic, that their radiation physically burned a hole through this cosmic fog. The ultraviolet blast from their accretion disks literally tore the electrons away from the surrounding hydrogen atoms, carving out massive, transparent bubbles in the dark. We are not just seeing ancient galaxies, we are seeing the exact mechanisms that forcibly cleared the darkness and allowed the universe to become transparent. We are witnessing the brutal, heavy-handed engineering of reality itself, but the paradox deepens when we examine the thermodynamic cost of this violent clearing. To clear that fog, to burn that bright, a black hole must consume an astronomical volume of matter. But every action in physics has a ruthless consequence. As the black hole feeds and blasts out this fierce radiation, it aggressively heats the surrounding environment. In our modern universe, when the gas inside a galaxy becomes too hot, star formation simply shuts down. The gas particles are moving too frantically, possessing too much kinetic energy to ever succumb to gravity and collapse into new stars. A feeding supermassive black hole typically acts as a sterilizer, cooking its host galaxy and preventing any further growth. The spectroscopic data from the little red dots reveals this exact thermal signature. The gas swirling around these objects is boiling. It is violently turbulent, whipped into a frenzy by the intense radiation of the central singularity. This creates an inescapable contradiction. If the black hole is heating the galaxy so violently, how is there still cold, dense gas available to feed it? It is an engine that should have choked on its own exhaust almost immediately after igniting. By all known laws of thermodynamics, The moment these black holes reached a few thousand solar masses, they should have blasted their fuel source away, starving themselves into a permanent, frozen slumber. They should have stopped growing. Instead, the data shows them devouring mass at a rate that treats the laws of thermodynamics as a mild suggestion rather than a physical law. They are somehow bypassing the heat death of their own environment, pulling in vast rivers of material through the scorching radiation field. Some physicists have proposed desperate theories to bridge this gap. They suggest that perhaps the gas in the early universe was not behaving like a fluid, as it does today, but rather falling into the black holes in hyperdense, cold, indestructible clumps. Imagine throwing a bucket of water into a raging fire. The water evaporates instantly. But if you compress that exact same water into a massive, solid block of deep frozen ice and hurl it into the flames, it will punch right through the fire, surviving long enough to reach the core. If this cold stream accretion theory is correct, the infant universe was dominated by immense dark rivers of dense matter, threading through the cosmic web and force-feeding these black holes in total defiance of the radiation trying to push them away. But even if we accept this radical thermodynamic workaround, we are still trapped by the information paradox. In quantum mechanics, there is a sacred, unbreakable law. Information can never be destroyed. The physical properties of every particle, its spin, its mass, its charge, must be preserved in some form forever. But a black hole operates as the ultimate cosmic eraser. When matter crosses the event horizon, it is entirely stripped of its identity. A star, a planet, or a cloud of dust. Once it falls in, it leaves behind no information other than its raw mass, charge, and spin. Stephen Hawking proved that black holes are not entirely black. They slowly leak radiation over trillions of years, evaporating back into the void. But this Hawking radiation is entirely random. It contains no trace of the matter that originally fell in. The information is gone. If the little red dots consumed hundreds of millions of solar masses of primitive gas in a fraction of the time allowed by our physics, they acted as the most efficient engines of destruction the universe has ever known, wiping out an incomprehensible volume of quantum information right at the dawn of time. They did not just shape the early universe, they permanently deleted a massive portion of its initial conditions. We are standing at the edge of an intellectual abyss. The James Webb Space Telescope was designed to peer into the deep past and confirm the elegant, slow mathematical models we spent decades perfecting. Instead, it has handed us a collection of crimson pixels that dismantle our understanding of space, time, gravity, and thermodynamics. The machines we built to decode reality are telling us that the rules do not apply in the dark. The foundation of the cosmos is not built on a steady, logical progression. It is built on something far more hostile, something entirely alien to the physics we teach in our universities. The math is broken, the horizon is blocked, and the immense invisible gravity of these ancient ghosts is pulling our entire theoretical framework into the dark, leaving us with a chilling realization about the nature of the void. The implications of these little red dots extend far beyond the fractured math on a physicist's chalkboard. When a fundamental theory of reality breaks, the fracture does not stay neatly contained in the realm of the abstract. It bleeds into the physical world. It forces us to look around our quiet, stable solar system and realize that the peace we experience every day is not the baseline of the cosmos. It is an anomaly, a temporary shelter built in the dead center of a cosmic hurricane. For generations, humanity has comforted itself with a deeply arrogant assumption. Because the Earth orbits a steady, medium-sized star in a quiet, sprawling suburb of the Milky Way, we assumed the universe was fundamentally a nurturing machine. We believed that reality was designed, over billions of years, to eventually produce biology, consciousness, and order. We view the cosmos as a grand theater built specifically for our existence. But the crimson data tearing through the James Webb sensors violently corrects this illusion. The universe is not a nursery. It is a graveyard, and we are simply living on the cold ashes of an ancient, unimaginably violent war. To understand our actual place in this machinery, we have to zoom out and look at the macro structure of reality. When astronomers map the entire observable universe, Galaxies are not scattered randomly like dust on a table. They are strung together in massive glowing filaments spanning hundreds of millions of light years, forming a sprawling architecture known as the cosmic web. Between these glowing threads are the voids, immense suffocating oceans of absolute nothingness where not a single star shines. We used to believe this web formed slowly, woven over eons by the gentle, patient pull of dark matter. We thought gravity took its time, slowly pulling scattered gas into these grand formations. But the little red dots suggest a far more brutal architecture. If supermassive black holes were fully formed just moments after the universe cooled, they were not just participants in the early cosmos. They were the architects. They were the original heavy anchors of reality. Their immense gravity served as the foundational pillars that forced the cosmic web into shape. Every modern galaxy, every star, and every planet that exists today was dragged into position by the gravitational shockwaves of these ancient feeding monsters. We are not the pinnacle of cosmic evolution. We are the leftovers. We are the silent secondary byproduct of a violent process that finished its most important work 13 billion years ago. Think about the iron in your blood, the calcium in your bones, and the oxygen in your lungs. We rightfully trace these elements back to the cores of dying stars, but the only reason those stars had the necessary gravity to form, the only reason they were gathered into a galaxy capable of sustaining a stable solar system, is because an impossibly dense, invisible sinkhole in the infant universe dictated the flow of mass. We owe our existence to the most destructive engines in nature. We are simply the moss growing on the ruins of a collapsed empire. And if these ancient black holes dictated our origin, they also hold the absolute monopoly on our future. The timeline of the universe is not a circle. It is a straight, irreversible line pointing directly toward exhaustion. Right now, we are living in the stelliferous era, the era of starlight. It feels infinite to a human mind, but in the grand mechanics of cosmology, this era is nothing more than a brief blinding flash. It is a temporary chemical reaction. Stars burn through their hydrogen fuel with ruthless efficiency. And because the universe is expanding so fast that distant galaxies are being pushed over the cosmic horizon, the supply of fresh gas is permanently cut off. The fuel line is severed. There will come a definitive moment in the deep future when the last cloud of gas collapses and the final star in the universe ignites. It will most likely be a red dwarf, a dim, shivering ember burning slowly in an incredibly vast and expanding dark. And then, trillions of years from now, that final star will flicker and die. The era of starlight will end. The universe will plunge into a permanent, freezing twilight. But the universe will not be empty. Long after the stars have gone cold, long after the planets have been torn from their orbits and shattered into frozen dust, by close gravitational encounters, the real masters of the cosmos will remain. The black hole era will begin. The supermassive monsters that hid inside the little red dots, the seeds that anchored the first galaxies, will still be there, drifting through an ocean of absolute pitch black. They are practically immortal compared to the fragile, burning stars. They will feed on the frozen wreckage of the dead galaxies, swallowing the cold remnants of planets and dead suns, growing heavier and darker in a universe that has completely surrendered to the void. Imagine a reality where the only sources of gravity are invisible spheres of crushed space-time. There is no light to reflect off them. There is no warmth. There is only the terrifying, silent deformation of space as they occasionally encounter one another in the dark, merging in violent, invisible collisions that send ripples of gravitational waves across a dead, empty vacuum. This is the true equilibrium of the universe. The brief window of warmth and light we are experiencing right now is simply the universe burning off its initial chaotic energy before settling into its natural state of cold, eternal silence. The little red dots captured by the Webb telescope are not just anomalies in the distant past. They are the heralds of this deep future. By showing us that black holes dominated the very first moments of the cosmos, they confirm that black holes will be the final actors on the stage. The universe began with these immense dark engines, and it will die with them. This completely reshapes the philosophical weight of our own existence. We spend enormous energy trying to preserve our history. We beam radio signals into the void. We etch maps onto golden records and hurl them out of the solar system in a desperate bid to be remembered. We want the cosmos to know that we were here, that we thought, that we felt. We want to believe that information is permanent. But the physics of these ancient black holes teach us a bitter lesson about the futility of memory. The universe is an active erasure machine. It is deliberately deleting the evidence of its own history. The same dark energy that stretched the light of those ancient black holes into the infrared is currently accelerating the expansion of our own local space. Right now, every galaxy outside of our local group is flying away from us. Because this expansion is accelerating, they are moving away faster and faster. Eventually, they will cross a physical threshold where the space between us is expanding faster than the speed of light. When that happens, those galaxies will disappear from our sky forever. Their light will never ever be able to reach us again. If a civilization were to arise in our own galaxy a few 100 billion years from now, they would look up into the night sky and see absolute unbroken blackness. The cosmic horizon would have pulled all other galaxies out of view. They would have no evidence that the universe was ever expanding. They would have no evidence of the Big Bang. The background radiation of the cosmos would be stretched so far, it would become entirely undetectable. They would believe with absolute scientific certainty that their single isolated galaxy was the entire universe, suspended in a timeless, static void. The only reason we know about the dawn of time, the only reason we can capture the faint crimson light of those impossibly heavy early black holes is because we happen to exist in the incredibly narrow, privileged sliver of time. We are living in a temporary window where the universe is old enough to have produced intelligent life, but young enough that the evidence of its violent birth has not yet been pushed over the edge of reality. We are catching the last fading echoes of the truth before the universe permanently buries them in the dark. And what those echoes are telling us is deeply unsettling. The foundational rules of reality are fluid, dangerous, and completely indifferent to the structures of light and warmth we value. The discovery of these impossibly heavy singularities proves that gravity can rewrite the laws of thermodynamics when pushed to the extreme. It proves that the very fabric of spacetime is capable of producing spontaneous, catastrophic mass in conditions we previously thought were safe. We are studying a monster through the lens of a telescope, safely separated by 13 billion years of distance. But the physics that allowed those supermassive black holes to form so quickly are not gone. The equations have not changed. The laws of nature that permitted the sudden, brutal collapse of millions of solar masses of matter into a single point are still woven into the fabric of the space surrounding us right now. We are simply floating in a region that is temporarily too calm to trigger them. The most chilling aspect of the little red dots is not that they break our current models of physics. It is the realization that our models were built on a fundamentally flawed premise. We looked at a calm, dying ocean and assumed the water had always been still. We did not know we were standing on the wake of a leviathan that had already passed through. We look up at the night sky and project our own meaning onto the darkness. We connect the faint points of light to form constellations, heroes, and mythologies, convincing ourselves that the cosmos is an open canvas waiting for human interpretation. But the universe is not a canvas. It is an indifferent, calculating machine. And the data from the James Webb Space Telescope has laid bare the cold mechanical truth of its design. We are not the masters of this reality, nor are we its ultimate purpose. We are an accidental byproduct, a fleeting, fragile chemical reaction occurring in a temporary lull between two eternities of absolute darkness. When we stare into the deep infrared, looking at those microscopic crimson smudges, we are forced to strip away our biological arrogance. We like to think that life is the highest expression of cosmic evolution, the grand finale of billions of years of cooling gas and condensing stars. But the little red dots tell a radically different story. They tell us that the universe did not spend its youth carefully preparing a cradle for biology. It spent its youth forging monsters. The most efficient, dominant structures in reality were built in the shadows, locked in place long before the first planets even had a chance to solidify. We are a whisper in a storm, a microscopic configuration of dust sitting on the frozen ruins of a gravitational war that ended 13 billion years before we opened our eyes. This realization brutally shatters the illusion of permanence that drives human civilization. We build cities out of stone and steel, we archive our history on massive global servers, and we hurl titanium probes out of the solar system with golden records bolted to their hulls. We do all of this because we are fundamentally terrified of being forgotten. We demand that the cosmos remember our existence. But the physics of the early universe show us that reality does not possess a memory. It is a system built on violent, irreversible erasure. The supermassive black holes lurking in the cosmic dawn swallowed millions of suns whole, crushing their physical matter and quantum information out of existence in the blink of an eye. If the universe was willing to blindly delete the colossal architecture of its own violent birth, it will not hesitate to delete the microscopic friction of human history. The stelliferous era, this brief, blinding period of starlight and warmth that we mistakenly call the baseline of reality, is already winding down. The cosmic fuel lines are severed. The expansion of space is aggressively accelerating, dragging the galaxies apart, isolating every star system in a rapidly growing ocean of nothingness. The night sky is actively emptying itself, preparing for the final phase. Our own sun will eventually swell, consume the inner planets, and collapse into a shivering white dwarf. But in the grand mechanics of the cosmos, the death of our solar system will not even register as a spark. It will be a silent, unseen event in a universe that has already surrendered to the void. Trillions of years from now, long after the last star has frozen into dark iron, the supermassive black holes will be the only structures left. They will drift through an endlessly expanding, utterly silent vacuum, occasionally consuming the cold, dead wreckage of forgotten galaxies. They are the true, permanent inhabitants of the cosmos. The universe was designed by their gravity, and it will die within their event horizons. We are merely the ghosts haunting the temporary background. When you look out into the pitch black of deep space, you are not looking at a puzzle waiting for a human solution. You are looking into a mirror reflecting our own absolute terrifying insignificance. The universe does not care that we are here. It does not care that we have decoded its mathematics, and it will not pause for a fraction of a second when we are gone. The James Webb Space Telescope has peered into the deepest abyss of time and found the original architects of reality waiting for us in the dark. The light from those impossible crimson dots has finally arrived, completely exhausted, not to answer our prayers, but to deliver a cold, inescapable truth. The dark is not empty, and it has always belonged to them.